So as we have already learned the triangle law and parallelogram law and their result and their derivation, everything we have learned. So based on that, we can easily solve this question. The question is saying two forces 10 Newton and 40 Newton are acting upon a body. What can be the maximum resultant force on the body? Cool. So see, I had told you two special cases, the case of maximum resultant and case of minimum resultant. According to that, when two forces act upon a body or act on the same direction parallel to each other, then that time the resultant is maximum. So the maximum resultant can be 10 Newton plus 14 Newton, that is 24 Newton, and the minimum resultant will get when two forces act opposite to each other, that is 14 minus 10, 4 Newton will be the minimum force on the body. But we're not gonna do theoretically, but rather than we're gonna show it, and we're gonna learn by the formula, so let me try to show you more. All right, so let's say we have a body, let's say this is a rock. I'm not talking about that muscular rock. Okay, so this is rock, and let me say I want to find out the maximum resultant. All right, so here is force F1 of, let's say, 40 Newton, and here is force F2 of, let's say, 10 Newton. All right, so how this force should act on this rock so that the final resultant should be, maximum, and how much is that? And the final resultant should be minimum. How much is that? And for the resultant, what we had learned in the triangle law, not the triangle law, while doing the derivation of the triangle law, we find out that the resultant of the two vector with acting with certain angle theta is, let's say, p square plus q square plus 2pq cosine of theta. All right, this was the resultant. Here p represents f1. All right, I'm going to say this is f1 and this is f2, so this will be f1 times f2. This is the magnitude. All right, in that case, if you go, so how I can get the maximum resultant? All right, so I will get R maximum when the cosine of theta is going to be 1, and I will get minimum when these whole things will be minimum. All right, so for R max, cosine of theta should be 1, because the value of cosine can be from -1 to positive 1. All right, so I need maximum value, so I need +1. All right, so that plus 1 will be f1 and f2, and then I can add with them. So according to that, my resultant maximum will be f1 square plus f2 square plus 2f1 plus times f2. Right, this is the magnitude of the f1. all right, keep in mind that, and this is the magnitude of the f2. Okay, so it's simply actually f1 plus f2. all right, whole square. This is magnitude, always keep in mind. All right, inside the root, so it's simply f1 plus f2. all right, okay. So according to that, f1 is our 14 Newton and f2 is our 10 Newton. So it's going to be 24 Newton. All right, and cosine of theta will be 1 if theta equals to 0 degree. All right, and 0 degree, it means when f1 and f2 are acting up on the same line, up in the same direction. All right, I mean to say f1 is acting 14 Newton in this direction, and when f2 is also acting into the same direction with 10 Newton parallel to each other, then that time the resultant force R will be maximum as a 25 Newton. And now I need the minimum. All right, how can I get the minimum? So to get minimum, if we make this negative, then from the sum of the square of f1 square and f2, we're going to subtract a very big thing. All right, so that time we need rather than +1, we need -1, because the cosine of theta, as I told you, can be +1 and can be -1 also. So when +1 will get maximum, and when it is -1 we'll get minimum. All right, so the value of cosine of theta is -1 when theta equals to 180 degree. 180 degree means opposite. All right, so opposite means when f1 is acting towards this and f2 is acting right opposite to the direction. All right, right opposite to the direction. So for our minimum, cosine of theta should be -1, and that time our minimum will be f1 square f2 square minus 2 f1 magnitude of f1 times magnitude of f2. All right, and this is actually the formula of a square plus b square minus 2ab, so it means it's f1 magnitude of f1 minus magnitude of f2 whole square. All right, and these all are inside the root, so this will cancel up and I will get f1 minus f2. All right, these are magnitude again, keep in mind. So f1 is 14 Newton and f2 is 10 Newton. It means 4 Newton is the minimum resultant. All right, so when the two forces are acting oppositely, right, opposite to each other, then that time the resultant will be minimum, and that is 4 Newton. And as we had learned in the special cases, case of maximum and case of minimum, based on that, this is the example. All right, I hope you understand it. We're going to learn so many different type of the problems and more concept on vectors, so please keep on watching and please subscribe the channel.